All right, so happy return to the video. So this is a test on relationships between the different angles, midpoints, medians for triangles, quadrilaterals, parallelograms, polygons. Okay, so a lot of different relationships. So you can test yourself with this one. I will put in the show notes a link to this test so you can download it and try it on your own. It's not an easy one, I don't think. Okay, so it is based for grade 9, but it should challenge you a bit. I didn't want to just make a plain test for you. So there's X amount of questions here. I'm going to walk through those questions. I hope that you can try to do these on your own and then return to this video. Now, one note. So I have provided kind of little mini lessons on all of these different topics. I'm going to put a link up above to the playlist to all of those. And I will also be kind of pointing out certain videos and pointing out links as I go through this video. All right, so question number 1. So given a triangle with two exterior angles of 130 and 110, I guess that's degrees, find all interior and exterior angles. Okay, so draw a diagram to illustrate. All right, so it doesn't have to be to scale. So let's do this one. So I'm going to draw again. So I'm going to just draw a basic, okay, so triangle here for us. So let's do something like that. All right, let me just kind of make it a little bit funky here. And now, so it says exterior angles. So the two exterior angles that I have, so remember, so our exterior angles, so I'm going to extend, so all of these, all right, just so that we can see the exterior angles. And actually, let me hold on a second here, let me shift this down. So we have, okay, so here is, so we're going to have interior angles. So that's going to be, let's say, A, B, and C. And our exterior angles is A prime, B prime, and C prime. Okay, so those are exterior angles. Now, we know two of them. So just by kind of eyeballing it, so I'm going to say, 130 and 110. So let's say that this one is 130 degrees. This one right here is 110 degrees. Now, if we want to be able to find all the interior and exterior angles, we can do that by using the various things we have learned. All right. So first of all, so supplementary angles that we want to know. So that's something that we're going to use. So we can very quickly find out what the angle A is. And that will be 50 degrees because supplementary, so they should add up to 180. So there you go. We have A. Same thing for B. So we can do that as well. So that's going to be 70 degrees. Again, so the reason is because 70 degrees plus the 110, it's going to be 180. So we have that. Now finding C is easy because we have A plus B plus C is equal to 180 degrees for all triangles, right? So that's what we have there. And since we know, so this one was 50 degrees, this one is 70 degrees, then we can find out what C is. So 50 plus 70 is 120. So that means that C has to be 60 degrees. So this one is 60 degrees. Now, if I know that, again, I can find the exterior angle C kind of prime, again, by supplementary angles. So that's 180 minus the 60, so this one is going to be, okay, 120. So that's how we would find all the different angles for question number 1. All right. Question number 2. So for question number 2, so it says, if you know two interior angles of a quadrilateral, then is this enough to find all other interior and exterior angles? So this is kind of a thinking one instead of just solving it. So it really tests your ability to understand, right, the differences and what happens with these quadrilaterals. So quadrilaterals are basically, so we have a four-sided Okay, figure, so it could be like this. And so we have angles A plus B plus C plus D. Now, we know what the sum of the interior angles is, and we also know what the sum of the exterior angles is for quadrilaterals. And for quadrilaterals, I'll point up to the video up above. I'll do a direct link in case you want to watch that little short lesson on those. So the summation of interior angles is 360. Now, if we know two of the angles, is it enough to find all other ones? Well, the answer is actually not always. So there are some cases. So it says, is there a case? Now it says explain. So I mean, here is an example, for instance. So we could know two of these angles. So let's say if we knew these two angles, now this one looks like it's an acute angle. The other one looks like it's an obtuse angle. So this one, let's say if it was 60 degrees, all right, and let's say if this one was, let's say 120 degrees or something like that. Let's make it, okay, so let's make this one, let's say 130 degrees, all right. So with this, these are the two angles that we have. Now, is it enough? Okay, to find out C and D? The answer again is not always. If we knew something, if for example this was a parallelogram, right, or if it was just a regular rectangle or something like that, then we could find out a bit more. Now in this case, you know, if you add these up, so 60 plus 130, so in this case it would have been 190. So we know that C plus D, so if A plus B is equal to 190, that means that this one has to be 170. But we don't exactly know what those angles could be. All right, so that will depend. Okay, so what happens? And notice that, you know, this can change because what we could have done is, okay, so this line segment that starts from here, you know, it could have went like this. All right, okay, or it could have went this way. So notice we could change this thing and the angles would change, and they're still quadrilaterals. So for instance, these angles C and D are different than if we had it like this, or if we kept going and it was like this or like this. Okay, so notice that the angles will depend, okay, on the actual structure. All right, so that's one explanation that you can have, is because you can actually change the side. Okay, so the answer is no, it's not enough just to know two of them. Now, is there a case? Yes. So if you've watched the video on quadrilaterals, you may remember. So if you have parallelograms, in parallelograms, really, we just need to know one, because the parallel lines will give all the other angles away. The same thing will happen with if you have a square, then obviously the angles are all 90 degrees. And the same thing happens with a rectangle. And I guess the last one could be a rhombus, right, which is a square kind of shifted. So if you knew two of those, then those ones you could kind of find out the rest of the angles. And that's just by the properties and relationships of parallelograms and squares and rectangles. All right, so that is question number 2. Okay, and this one is definitely a good one because it makes you think. Question number 3. So for question number 3, we have explain the difference between a concave and a convex polygon. Show an example of a concave polygon. All right, well, so for concave, okay, and convex polygons, what I'm going to do is I'm going to put a link to the video on polygons, okay, and relationships there. So first, convex polygons, so you may remember, this means that every single angle was less, okay, than 180 degrees, all right? So all the angles were less than 180 degrees. So that's what we had there. For concave, okay, so the difference is that at least one angle, so at least one angle, so this here was for all your angles, one angle is more than 180 degrees, all right? And so that's what you would have. Now, we can do a simple example of this. So for instance, can do, so here we go. All right, so here is a polygon. It's actually even a quadrilateral polygon. Okay, so it has 4 sides. And here is, so notice, so this one, so this angle, this angle, this angle, but this angle right here is definitely more than 180 degrees. And you can do that with any polygon, right? So you can create those if necessary. So that is question number 3. So question number 4. So for question 4, it says, what is the sum of the interior angles of a convex hexagon and an octagon? So this again is still in polygons. So this is something that you may remember, all right? So depending on how often you do this. I mean, if you stay away from this work, you probably will forget. I mean, I typically forget if I don't actually go over this once in a blue moon, all right? So the summation of angles for any polygons that we talked about, again, it was in the previous link, okay, on polygons if you wanted to go back to it. Okay, so we know that for any polygon, all right, so what we have, okay, and this is for convex polygon. Okay, so here, so the summation of angles, okay, so the sum of all the angles, so I gotta kind of rewrite this, so polygon angles, okay, so they sum up to basically 180 degrees multiplied by the n minus 2, okay, where n is the number of sides that they have. So a hexagon is 6 sides and an octagon is an 8-sided polygon. So in this case, if it was a hexagon, so you would say 180, all right, n is 6, so 6 minus 2, so this is 180 times 4, all right, and you can get your answer. Okay, so that would be 720 in this case. And then for the octagon, so you would have 180, now it's 8 minus 2, so this is 180 times 6, and there you have it, and you can punch that in to the calculator if necessary, all right? So, you know, if you're kind of uncertain, you can do it on the side for yourself as well. So this is 1080, right? And as we said, so the other one was 4 times 180, okay, which was 720. So that's what we would have for these two, and that is basically coming from this little formula here. And we did talk about the derivation, all right, within the video. So that is question number 4. So this is another good one. Question number 5. Are two triangles always congruent? So first of all, congruent, all right, so on congruency, I'll put a link up above to that video for you, okay, so just that you have it. And congruency of triangles, so this was kind of, you know, the idea that we would have, you may recall. So if all the sides are the same, for example, if you have a side angle side, all right, and then so on, so you can look at the video, so those ones that we have. But here it says all the angles, so that means all the angles would be the same. I mean, it would be great if they were congruent, but is this always true? Well, it's not always true, okay? So it is not always true. Explain why or why not. Okay, so for instance, so here, if you take a triangle, and I'm just going to show a simple example here, okay, and typically, you know, to disprove something, you really need just a simple one. So notice, so we have, so this is angle A, angle B, and angle C. All right, so this is what we would have there. Now, with this, you can have exactly the same triangle, but you can scale it, right? You can scale the sides up and down, but keep all the angles the same. And, you know, so I can take this, I can, let me duplicate it here, and then make it smaller, right? Okay, so here, you know, I'm making it smaller, but it's exactly the same angles. So those angles are going to be the same. So they're not congruent, they're similar in some way where the sides are basically proportional to each other. Okay, but it is not enough just to have the angles. So keep that in mind. And we've seen this one actually. If you take the midpoint, so within here, so if you take the midpoint here and you connect the midpoint, you know, we saw that, notice, so this is, you know, so the smaller triangle, let's call this smaller triangle A, and then the overall triangle, which would be this one right here. All right, so these ones have exactly the same angles, but they're not congruent. All right, so that's something that you can think about. So that was question 5. Question number 6. How many sides does a polygon have if each angle measures 150 degrees? So this is a great question. So what do we know about polygons, right? And what do we know about their angles? So here, well, we do know that all polygons, so we have 180, let's say n minus 2. We know that the summation of all the angles is equal to this if we know the number of sides, right? So whatever that would be. Now, because they give us that each angle is 150 degrees, so this is like a regular polygon basically, where all the angles are the same. So in this case, well, if we know that each angle is 150 degrees, if we know, so notice the number of sides is equal to the number of vertices and angles that you have. So you can equate these. This is coming from the formula. So this right here is 180 in brackets n minus 2. And then if you know how many angles you have, which is the same as the number of sides, and you multiply it by 150, then you actually would know. So you can solve this for n. So if I bring this inside of the bracket, so this is 180n minus 360 is equal to 150n. Now let's solve it for n. So I'm going to bring the 150 over, the 360 on the other side. This is going to be 30n. And notice divide both sides by 30. Okay, and if you divide both sides by 30, I guess you're going to get 12. All right, so it has 12 sides. So how many sides? It has 12 sides. So that's a nice question on testing you about polygons. Okay. Question number 7. So for question 7, it states, given a parallelogram with one interior angle of 50 degrees, find all other interior and exterior angles. So this is testing you back on quadrilaterals. And so here, so a parallelogram. So if I draw a parallelogram, oh, I'm going to try to draw a parallelogram. Okay, let me try it here so that it kind of lines up. But I think you know what we mean here. So these are parallelograms. So what did we know about parallelograms? All right, so for parallelograms, because you have, okay, so for instance, this line, right, is parallel to this line. Okay, and this right here is just a transversal, for instance. So that's a transversal right there. So if we know, so let's say if this is 50 degrees, then we actually know quite a lot. Okay, so for this one. Okay, so for this one, again, because of the transversal there, okay, so I know right away that this angle is 130 degrees because you have the parallel lines. So we know that. All right, so that's one thing that we know. And the other thing that we also know is, okay, we can find out, you know, these angles. So let's call this angle A and then angle B. Okay, and you will find that the angle A is 130. So this is 130, and then this will be 50. Now, what's the reason for that? And the reason is actually exactly the same, because now what you can look at, so for instance, you may remember this. Okay, so let me erase this right here. Okay, and let me show you in this way. So now what we have is Okay, so these again, so these two lines so are parallel for us. And then now I'm going to say this is now the transversal, all right, okay, which makes, all right, this to be 50 degrees because it has to be supplementary. And then you can do the same thing over here, all right. So we know all our interior angles, and you'll see that they, in this case, will sum up to 360 again because it's a quadrilateral. Now, can we find the exterior angles? So, you know, can we find this angle right here? Can we find this angle right here, this angle right here, and this angle right here? Of course we can, and I can leave that to you, okay, because again it's supplementary. So wherever it's 50, it's going to be 130, and wherever it's 130, it's going to be 50 as your exterior angles. So that's what you'll have for your parallelogram. So another great question. Question number 7. Okay, so here is a question where it says find angles A, B, C, and E. So A, so this is B, so A, B, C, and E. I guess it was lined up with the vertices, okay, of B and then so on, and A. So if we want to find these, okay, so notice one thing. Okay, so this is testing you. Okay, so this right here and then this right here. So this means that these two are equal, right? On the left and then on the right. So that means this point that we have, so this point is the midpoint, okay, and this point is the midpoint of that line segment. And if we know it's the midpoints, then we also know that this must be parallel to this. And this is coming from the triangles, okay, and the midpoints, okay, and medians video, and I can put a link up above to that if you want to see it, okay, to see some details. Now, if we know those are parallel, then that makes life a lot easier for us. So, okay, so right away we will know that this is 40, okay, because it's creating an F, okay, for us with those parallel lines. We know as well, so if this one is 40, okay, we can take a look and see E. So for E, because of the supplementary angle, okay, so those have to, so E plus 125 has to be equal to 180. All right, so that's going to be what, 55 degrees, I guess. Okay, so E is 55. All right, now we can find out A because we have a triangle there. So that A, okay, so notice 40 degrees, okay, plus 55, so that's 95. And now 95, okay, in terms of getting it up to 180, okay, so that's going to be, I guess, 85 degrees. So that's A. So A is 85. And then we also know C, and then C is also 55 because of the parallel lines. So this is kind of neat, okay, and now we found all the angles, okay, so that tests your understanding of those medians, all right, that we had, the midpoints. So that was question number 8. Question number 9, so here it is, make this a little smaller. So below you see a concave polygon, so that is true. So we have a concave polygon in here. Okay, so so we have all these vertices, so whoops. So we have 1, 2, 3, 4, 5, 6, 7, okay, 8, 9, 10, 11. So I guess this is going to be 11-sided. Can you prove that the sum of all the interior angles of this polygon still is equal to 180 times n minus 2? All right. So, I mean, there are 11 sides for this one. All right. So we have, okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So just like the vertices. So this would have been 180. Okay, so 11 minus 2, and that's going to be 180 times 9. All right. Now, how can we prove this? Okay, so this is a great question. If you would go back, okay, and you study the polygon and angle relationships video that I pointed out before, so in that video, we came up with this formula by kind of breaking down polygons into triangles, because we know that a triangle, the interior angles of a triangle, are equal to 180 degrees. So in this case, we have a lot of angles here, right? We have, okay, so 1, 2, notice these ones, okay, it's definitely concave. So we have these angles in here, and we have to be able to sum all of them up. That's what they're asking us to do. Okay, and that formula comes from counting those triangles. So I am literally going to break this down into triangles to try to show you, all right, so how this can be done. So I'm going to be starting to connect all these vertices and all these triangles as best as I can. So for instance, okay, so what we have is, so if I connect this, so let's say this is triangle number 1 here, all right? And notice that breaks those angles up. So that's 180 degrees already, all right? So we're supposed to get, so notice 9, okay? So we should get 9, because if we get 9 triangles, okay, every triangle is 180 degrees. So here's another one. So this is another one. So that's number 2, okay? So now I've covered that. Okay, so now here is number 3. Okay, so that's number 3. Okay, so now here is going to be number 4. All right, so notice that those angles, okay, we're just cutting them up. All right, so that's what we have there. So here is number 5. Okay. Here is another one. So here's number 6. Here is number 7. So 7. Here is number 8. Number 8. And then here's number 9. And notice when you count up all those angles, okay, so for instance, you know, you may be wondering, like, does this really work? Okay, so notice that this angle is actually covered by the triangle 1, 2, 4, and 8, and 9. All right, so you have to add all of those up, okay, and you can do that to the rest. So we indeed have 9 triangles in here, all of them 180 degrees, and therefore indeed that's what it would be. So it's interesting because even concave polygons, you know, you can kind of try to convince yourself that they also have, okay, this formula within here. Okay, so that was question 9. Very hard one. I wonder if anybody got it. You can put it in the comments if you understood it or not. You know, I'm curious, guys. These questions are rather tough. Okay, here's another couple challenging, very challenging questions within here. I doubt that you would probably get this in grade 9 in terms of questions, but I'll try to give you some hints with these, okay? And I did cover them in the video, so I'll mention that. So in a triangle, the point of intersection of the 3 medians is called the centroid. Okay, so draw a triangle with the 3 medians. Okay, let's do that. So this is what they mean. Okay, so let's say here's my triangle, and now I'm going to break this up. So we're going to go from here. Oh boy, a median somewhere in here. Say this is a median 1. Here is the other median. Okay, again, I'm kind of guessing here, so it'll be 2, and then here's the last one. Okay, and it'll be somewhere here. So what they're saying is that this point right here, so that's your centroid. All right, so that's your centroid. Now, you will notice that there are 6 smaller triangles. So that's true. We have 6 smaller ones. Now, okay, we know that this is the same. We know these two are the same because these are the same. Okay, because they're midpoints, right? All right. Okay, so that's what we have. And here is our centroid right there. So now with that, show that all 6 triangles have the same area. Boy, this is definitely a challenge. Do they have the same area? Okay, so first, this is what I'm going to show you. Let's just concentrate first on, okay, I'm going to try to help you along here. And this is really for those who are, who want to challenge themselves in some way. So these 2 triangles, all right? Oh, this didn't work very well. Okay, so these 2 triangles. Okay, let's call them, so X, X, okay? So the areas are the same. Why? Why do these 2 have the same area? Notice, their base, okay, so their base, which is right here, so their bases are equal. Now, what is the area of a triangle? It is base times height divided by 2. So they have the same base, okay, because there was a midpoint there. Now, is the height the same? Yes, the height is the same because of the fact that they are sharing the vertex at the centroid. So if I blow this up, okay, the height, I mean, really the height is going to be, right? So because the height is from the vertex straight down, right? And then it creates a right angle here. Okay. So notice, so that's the height, and they share exactly the same height. So they have the same base and the same height. Well, then the area is base times height divided by 2. So those ones are identical. All right. Now, the same can be said, okay, and this is what I'm going to do, is I'm going to take this, I'm going to rotate it for you, just so that you can now, I'm going to flip this like this. Notice that the same thing can be said about this. I'm going to call this area Y and area Y, because they have the same base, they have the same height. So these 2 also have the same area. Now if I twist this up again, notice I can do the same thing with this. So I can call this area Z and Z. So those ones have exactly the same base and the same height. So those areas are the same. Now let me flip it back to what it was originally, okay, which was that. And let me just, so that you can see these. So this was Y and this was Z. So those ones have the same. But what we want to know is, we want to basically say that these areas are the same. So all of them are the same. So how do we do that? So this again goes from understanding the bisect of a triangle, right? If you take a median and you take the bisect, which basically is, so the median will bisect the areas of a triangle. And this we've mentioned in the video. So if I take, okay, let me try to duplicate. Let's see if I can duplicate. Okay, perfect. So if I take this, I'm going to make it a touch smaller just so that you can see it there. So what I mean is, okay, so this was the line, this was the median, and it bisects So that means this area and this area are the same. Those are the same areas. So that is understanding, okay, what a median does to a triangle. Now, if you know this, okay, so notice that area 1, so this is what I'm going to show you here. Area 1 is equal to the area of X, so that's right here, plus, okay, 2y, right? Because there's two y's. And area 2 is equal to, again, X plus 2z. Now, these two are equal. So if you're going to equate these, so what you're going to get is you're going to say X plus 2y is equal to X plus 2z. Okay, so that's what you're going to have. X plus 2y is equal to X plus 2z, or z. Notice the X and the X will cancel on both sides, and you have 2y is equal to 2z, which means that y is equal to z. All right? So that's going to show you that y is equal to z, and you can do the same thing again, okay, with a different vertex. So for example, starting from here, and then take the median there and do exactly the same trick. And you can find, that then, x is equal to y and so on. You can do that to all of them and you will actually equate them. This is really challenging. If you understood this, definitely put a comment down. I'm curious if anybody understood it. As I said, this is a full-out challenge, okay, for anybody to understand this. But it's great because, in grade 9, nobody really does these things. They make you find angles and so on, and then you don't really think outside of the box. So this is a really good challenging question. The last question, which is a challenge, it says, show that for any quadrilateral, the connection of the midpoints for each side creates a parallelogram. Okay, so for this one, so if you have a quadrilateral, actually it's okay, it doesn't have to be perfect. Okay, I'm going to do that. Okay. And if you take a quadrilateral, this one actually isn't the greatest. You know what, let me just draw it randomly. Okay, so we have that. And if you connect the midpoints, all right, so if you're gonna, so this midpoint, 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 and now you create figure inside, what they're saying is that you've created a parallelogram. All right, and it says show that, and I did that in the video, and I'm gonna do a link, okay, if someone is interested in that, okay, to actually show it. So I know I challenged you on this test, okay, so some of these questions you definitely should understand, okay, and some of them are definitely tough, okay, so they're definitely tough. Now, by the way, for this question number 11, we're assuming that it's a convex, okay, quadrilateral there. All right, that's what we have. So you can do that. You can just make that assumption that all the angles, okay, are less, okay, than 180 here, so you can create this. All right. All right, so thank you for watching. You can watch all the linked videos, and this definitely will challenge you. And let's see what people will put in the comments, if they ever do. All right, okay, bye everybody, take care.